So it is not necessary that a node being marked down by N2, that hey N3, I'm marking you down, it does not necessarily mean that node 3 is actually down. So now the question is, if N3 starts gossiping again, what will happen? Heartbeat will change. So the moment N3, remember when N3 comes back, let's genuinely assume that yes, N3 was down. And when 3 came back up again, remember, it handshakes with all the other nodes. And the moment it starts handshaking with other nodes, don't you think that node will realize, oh, wait a minute, welcome back. I now have a new heartbeat that you're letting me know. Good. So that's how each of these nodes know, by virtue of node 3 handshaking as well as the gossip information, that a downed node which I had marked down is now up. So what will happen? In the list of nodes, in the list of peers that a node has, it's going to say, okay, good. I now will consider N3 as an up node, as a node that is up and running. And when I intend to gossip, I will consider N3 as a potential option to gossip with. Gossip is like the circulatory system of the human body. If the circulatory system stops, aka cardiac arrest, God forbid, should that happen to us, what's going to happen? The cluster dies, isn't it? So if gossip stops on a given node, that node will be marked as down by all of its quote-unquote peers. Okay? The other important point that I want to talk about in gossip is the process of marking a node down is called as accrual failure detection. And this is a very important term to keep in mind. And the reason why it is so is because when should node N2 mark N3 down? Is it a specific period of time? Or the number of constant heartbeats it gets to hear from its peers? It's the latter. So for instance, if I set a value which is called as phi convict threshold, PHI convict threshold, this value by default is 8. Now listen to this. If node N2 gets to hear the same heartbeat for 8 consecutive periods of time, that's when the node marks it down. Now it's got nothing to do with time. For example, in this node, in this cluster that's in front of you, when this node goes down, N1 is gossiping with N2 and chances are N4 is also gossiping with N2 every second. So first second, these two say heartbeat 1 for N3. Next second, these two say heartbeat 1 for N3. Next second, N1 and N4 says heartbeat 1 for N3. You understand this? So what will end up happening? So perhaps the time taken for the node to go down, right, may seem like, oh, looks like it's going to be 8 seconds. But that's not true. And here's why. Listen, N2 is also going to gossip, right? We just considered the situation that N4 and N1 have realized that N3 is down and only gossiping with the constant heartbeat, because obviously N3 is not gossiping, so heartbeats remains constant. But N2 is also gossiping. So consider a situation where N2 tries to gossip with N3 and times out. That's when N2 is going to realize, oh, wait a minute, I timed out with N3. That's not good. Maybe it'll try to gossip one more time. It'll time out again. Now, who do you think it's going to trust? Its own inability to gossip with N3 or other nodes telling, hey, you know what, you have a constant heartbeat. So N2 will mark the node N3 down if it fails to gossip with it. So it's not 8 seconds, it could be much earlier. This is in a small cluster. In a very large cluster, for example, I'm going to just draw a cluster with several nodes. And by the way, this representation is exactly the same as this representation. These two representations are identical. It just happens to be in a circle. That's all. Okay, it doesn't mean that these two are the edge nodes. No, not at all. Now let's consider this node. There are so many other nodes. What are the odds that, at this particular second, this node, this node, this node, this node, and this node, all 5 nodes are gossiping with this particular node? And you know what? All of them are saying, hey, this particular node's gossip remains constant. How many times has it this heard? How many times this node hears that this particular node's gossip information, heartbeat information is constant? 5 times. And this happened just in 1 second. In the next second, is it likely that at least 3 other nodes may have gossiped with this? It's likely. So you can't say, oh, wait a minute, in a large cluster, a node will be marked down slowly. It's exactly the other way around. In a large cluster, a node can be marked down very quickly because a number of nodes that are gossiping with you is larger. Going by just this large number, you will have enough information to say that, looks like 8 of you have told me exactly the same heartbeat. I'm marking you down. And similarly, it can mark a node up equally quickly. So my point is, at every second when a node gossips with every other node, in a large cluster, the number of incoming gossips can be very high, which helps you take a decision rather quickly. And the ability to do this, to look at multiple responses, 8 in particular, 5 convict threshold, that this is called as a accrual failure detector. And this is how gossip works in Cassandra. A stopped gossip means a downed Cassandra node.